Welcome, listeners. Today, we're exploring Galileo Galilei, the man who questioned everything. To begin, Galileo was born into a world where the Church firmly believed Earth sat motionless at the center of the universe. Why was this belief so foundational at the time?
Great question. The geocentric model wasn't just a scientific view, it was a cornerstone of religious doctrine. The idea that the heavens moved in perfect, unchanging circles around an immobile Earth reinforced a cosmic order that placed humanity at the center. Questioning it threatened both scientific and spiritual authority.
So, even as a young boy, Galileo was already poking holes in these assumptions. I've read that he was fascinated by simple phenomena, like pendulums and falling objects. How did this curiosity set him apart from his peers?
Unlike most, Galileo didn't accept explanations at face value. He preferred first-hand observation. For example, he watched a swinging chandelier in Pisa's cathedral and noticed its period remained constant regardless of swing size, a property now called isochronism. This type of questioning paved the way for experimental science, which was radical then.
That's an excellent point. It's interesting how a simple observation could outshine centuries of established doctrine. Let's transition to how this curiosity steered Galileo from medicine toward mathematics and physics. Galileo's journey took a sharp turn at the University of Pisa. He entered to study medicine, but was captivated by the laws of motion instead. What made him abandon a secure medical career for the uncertainty of mathematics and physics?
It was all about where his passion lay. Medicine was considered prestigious, but Galileo was enthralled by the mechanics of nature. Observing that swinging chandelier, he realized that mathematical principles could explain real-world phenomena, something medicine lectures didn't offer. This was a bold move, given the limited career prospects for scientists at the time.
It's reminiscent of modern students leaving secure paths for tech startups, high risk, high reward. Moving forward, can you elaborate on how Galileo's approach contrasted with traditional scientific methods of that era?
Certainly, medieval science relied heavily on Aristotle's authority and philosophical reasoning. Galileo, by contrast, emphasized experimentation and mathematical description. For example, he rolled balls down inclined planes to study acceleration, quantifying motion instead of relying on vague speculation.
That experimental mindset was revolutionary, laying groundwork for later giants. Let's segue now to Galileo's most iconic invention, his telescope, which truly brought the heavens down to Earth. Galileo didn't invent the telescope, but he perfected it. In 1609, he built a version that magnified up to 20 times. How did this seemingly simple device revolutionize our understanding of the cosmos?
The telescope acted as a portal into the unknown. Galileo's observations debunked the notion that the heavens were perfect and immutable. For instance, he discovered that the moon had mountains and craters, directly contradicting the Church's teaching of celestial perfection. It was as if he'd taken a magnifying glass to nature's secrets.
And then came his discovery of Jupiter's moons Io, Europa, Ganymede, and Callisto. What made this observation so earth-shattering?
This was a turning point. Observing 4 moons orbiting Jupiter proved that not everything revolved around Earth. It was concrete evidence supporting Copernicus's heliocentric theory. Imagine, for analogy, if we suddenly discovered a planet with its own system of satellites, it would force us to rethink our place in the universe.
He also saw the Milky Way resolve into countless stars, vastly expanding the scale of the cosmos. These findings didn't just challenge scientific models, they shook the very foundations of religious and philosophical thought. Next, let's discuss how Galileo's discoveries led him into conflict with the Church. Galileo's evidence threatened the Church's geocentric worldview. Publishing his findings in the Starry Messenger made him both a celebrity and a target. How did the Church initially respond to his claims?
At first, Church authorities issued warnings, asking Galileo to stop advocating heliocentrism. They saw his support for Copernicus not just as scientific dissent, but as potential heresy. For several years, Galileo complied, but scientific truth kept pulling him forward.
In 1632, Galileo published Dialogue Concerning the Two Chief World Systems, forcefully defending heliocentrism. The Church's reaction was far harsher this time. What happened next?
Galileo was summoned before the Roman Inquisition, accused of heresy, and forced to recant under threat of imprisonment. He spent the rest of his life under house arrest, continuing his research in secret. This scenario is a powerful example of the tension between established authority and evidence-based inquiry, a tension we still see in science today.
Indeed, even under house arrest, Galileo laid foundations for modern physics. After his death, his reputation grew, and he's now celebrated as the father of modern science. His story reminds us that, as he said, all truths are easy to understand once they are discovered. The point is to discover them.